This is Geometry, Unit 9, Quiz Number 2 review. We're going to place each figure in the coordinate plane, and we're going to assign coordinates to it. We wouldn't need the grid here, but to put it in standard position, we have a vertex at the origin. We want a length of s, whatever length that might be, so we have s, comma 0, and then we could have 0, comma t. You could have it go the other ways if you wish, but that would be a right triangle. That meets the requirements of having legs at s and t. We're going to have a square with units of 6. Now we would need a grid for this. Notice that a square is going to have perpendicular, so we're at 6, comma 0, then we're over 6, up 6, we're right and left 6, or I'm sorry, left and right 0, up 6, and of course at 0, 0. Even this first one we could label at 0, 0. So that makes our square. Here we're going to plot our points. 2, 2 is A. 4, 6. So we have point A, point B, point C and D. Now I can look at this and I can have a pretty good idea of what we're looking at. They're asking us to find the distance of each of these sides. So the distance of AB from A to B, that's 4 minus 2 squared and 6 minus 2 squared. That gives us 2 squared plus 4 squared, which is 4 plus 16, square root of 20. For BC, x2 minus x1, y2 minus y1, that gives us the square root of 4 plus 1, which is the square root of 5. So those lengths are different. CD, that is 6 minus 4 and 5 minus 1 gives us 2 squared and 4 squared. 4 plus 16 gives us 20 again. So we have opposite sides congruent. Now I'm going to try to get my next opposite sides congruent. So A to D, 4 minus 2 squared, 1 minus 2 squared, that's 4 plus 1, which is square root of 5. So I can tell this is not a rhombus, this is not a square, because all the sides aren't the same. That rules that out. Opposite sides being congruent definitely makes it a parallelogram. Now, we don't know if this is just a normal parallelogram or something special about the parallelogram. Let's look at the slopes. Slope AB is up 4 over 2. BC is down 1 over 2. Down 4 backwards 2 gives you a slope of 2. So these are the same. So that makes those two parallel. And then we also have from A to D down 1 over 2. That made those the same. So now we have two sets of parallel sides. So that definitely makes it a parallelogram, which we were pretty sure was true because of our two sets of opposite sides. But also look at the slopes. They are opposites of each other and they're reciprocals of each other. This would be 2 over 1. This is 1 over 2. And they're opposites. So we know that this shape is a rectangle because it has two sets of opposite sides congruent. It has two sets of parallel sides, and it has opposite reciprocals. For number 4, we have our 4 points that are all plotted on the grid. We'll find the distance. For AB, we have -4 minus 0 and 2 minus 3. That's -4 squared and -1 squared. That's 16 plus 1, which is the square root of 17. For BC, we have 1 minus 0. We have -1 minus 3. That gives us 1 plus 16, which is a square root of 17. So now it looks like these are going to become congruent to each other. CD, -3 minus 1, -2 minus a -1, when you minus a negative, you get a positive. That's going to give us 16 plus 1, which is a square root of 17. From A to D, -3 minus a -4, and -2 minus 2. That gives us a positive 1 actually, because that's -3 plus 4. Which is 1 squared plus 16, which is the square root of 17. So here again we have 4 congruent sides. Now that tells us that it is some sort of rhombus. We know it's a parallelogram, but it's some sort of rhombus because it has all the sides congruent. We got to check out the slopes to see if they're opposite reciprocals. From A to B, going up 1 over 4, down 1, actually down 4 over 1, down 1, backwards 4, up 4, backwards 1. So we have parallel sides and we have opposite reciprocals. So we have opposite reciprocals and we have all the sides the same. So the opposite reciprocals show us that we have a rectangle. All the sides the same tell us we have a rhombus. So this is a rectangle and a rhombus, which makes a square. The opposite reciprocals make 4 right angles. Last one. So here we have point A, point B, point C and D. So we'll look at the distances. AB, because it's horizontal, we can count 4. BC, x2 minus x1, y2 minus y1. Square root of 50. CD is 2 because it's horizontal, we can count that. CB, 5 minus 3. Let's see. AD. Sorry. Three minus 2 and 8 minus 1. There we go. 1 squared and 7 squared. Square root of 50. We have 2 sides that are congruent, but 2 sides that are not. Looking at the slopes, we have a slope of 0, rising up 0, over 4, which makes 0. The slope of BC, up 7, negative 1. DC, and then down 7, back 1. So that's positive 7. We have two slopes that are the same and two slopes that are opposites, but they're not reciprocals, they're just opposites. So they're considered different. We have one set of parallel sides. We have one set of opposite sides congruent. So this makes this an isosceles trapezoid. One pair of parallel sides, one pair of congruent trapezoid legs. Those are the non-parallel sides. I just wanted to be sure that it wasn't the parallel sides that were also congruent. That's another way to show a parallelogram. The parallel sides are not the congruent sides. Of the trapezoid, it's the legs of the trapezoid that are congruent. One pair of congruent legs from the trapezoid.